Hello everyone, this is my little draw bot. I haven't drawn the pen in yet. I'm going to make a lifter, but I'll put some holes here ready for screwing something I'll make out of. I'm going to sort of like 3D print something to go in here to hold the pen and move it up and down. Like most my jobs, what I'll do is I'll put a few more holes in this base plate so things can be screwed to it or added later on. A few extra holes doesn't harm it. Right, so I've drawn it and I'm making this video to talk about drawing a timing belt. This, if we look at this timing belt, we can see that it has to fit into slots on both sides evenly. Now, if these both these timing drives were both the same times, it's easy because you'll just make sure that you go within 2 mil of, you can go in 2 mil steps and add another one and just make sure the slot stays in and it'll be the same top and bottom. But the thing is, I'm putting a smaller belt, smaller gear on here, so in real life you'd just add this and then you'd just have this on a slide, which I've just done. Make it simple, I've just put a slide here which you can clamp and this will move to wherever it fits. But thing is, when you're drawing it, you want to be sort of in the right ballpark, so that it's going to fit. You don't have to put a real massive slider for it to clamp this and make it work. So yeah, I thought I'd do that. So now I've done this and I've made a cock up as usual. I drew my little jockey wheel last. What I'm using here is a bearing, so it swivels around the bearing, and another bearing here that it'll sit on and roll. So basically, this will turn into whatever direction we're going. But the thing is, to make this work, I've had to go down a certain depth. And if you look on the right here, if I move that down to the bottom, so when this hits the floor down here, I've made this wheel too small. Basically, what I was doing, I was trying to make things as small as possible. So I'm going to alter it, and then altering it. I'm going to show you what I did to make sure that this timing chain is in a reasonable direction. So first of all, what we need to do is I need to resize this wheel. So if we go to here and look at the wheel I've got, well, actually, what I'll do is I'll put the floor in there. I think I've done one there. Oh, there. So there's my floor. I'll get down there. So let's have a look at this again. So delete that, and we'll just bring that down to the floor. And so what radius have we got there? 24. Well, it's 25 mil that. There we go, 25 mil. And you can see I'm clashing now with this, so I'm going to have to move all that out that way. And I'm clashing with this here now. Now, I'm not clashing with the top bit. I could leave that where it is, but I'm going to have to move this battery back. So let's start with that then, shall we? So let's do our mods. And what I want to do is I want to move the back. What I'll do is I'll move them right to the back here. Let's start with this top panel. This one. Yep, this one here. So what I'm going to do is I'm going to get rid of all that. Get rid of that one. Right, now notice I've got a dimension on that one, so I'm going to have to replace that sometime. So let's just bring that across. So, no, let's fix that. And I've got it fixed on there. Or is it fixed at the other side? Let's find out. Rid of those. Now is it fixed? No, so that's not fixed anymore, and I can bring that. What I can't do, what I need to do is release this. So this is tied in somewhere. Probably by this here. So I'm just going to get rid of those as well. And get rid of those on this side as well. And that's not tied anymore. This tied still. Yeah, it is. This is tied. Oh, there we go. Got that there, tied it somehow. How is that going to the other side? Anyway, let's have a look in there. Let's just make it wireframe. And what I'll do, no, I think what I'll do is we'll get rid of the actual panels. Right, so let's just get rid of the nano board for now. Where was I? That's yeah, that's fixed that way. So what we're going to do is going to make that. No, actually that wants to move down. I should have left some others in there, but yeah, that is going to go across. Yeah, that's going to go across there. So, in fact, what was that? What did they have there? Yeah, yeah. So, leave that. Uh, there it goes. Right, what I'm going to do is I'm going to keep that central. Right, so that is fixed. What's fixing this? We've got that going across there. That's only fixed to this. Oh, it's this one here. Look, there we go. I've got that one fixed there. So now that should actually move. It says it should move. Oh, it moves the top one. Oh, right. Okay. Do that. Right, that's fixing that top there and that top there. So what I want to do is I just want to delete that one. And I want to keep that the same length. Yeah, so we'll have that there, and I'll just delete this one. So now the whole thing should just move down there like that. So that's what I'm trying to connect them two together. Line up. See what that one is. That's that. Or is it this one here? Right, wait a minute. I wish they'd go behind the actual sketch. What else is in front of the sketch now? Oh, that one. There we go. Oh, actually, I've done it. I thought I hadn't done it. The computer must have been a bit slow there. Right, so connect them, and let's just make them to tangent. How's that come? Oh, what's up to my computer? It's gone slow. Right, so I've moved my batteries down and we've got these down now. So for some reason these, oh right, yeah, it was this. So that, I don't know the radius. So I've got a 2 mil there. So that's, yeah, there we go. It's all fixed now. And what I'll do is I'll put some radiuses in here again. I deleted something I shouldn't really need it to. So yeah. Right, so that and that. Well, let's do it on this side. That and that equal to that one. So that's got that and that. The thing is, oh yeah, I want to make this central. So if I go like that and that, that'll line them up eventually. We do that one. And do the same here. There we go. We're all back together again. So that one should now, that one should look okay. And there we go. So I'll move that one back. And so we can move our batteries there now. Where's my battery? There's my battery one. And this one. So my batteries are going to sit there now. So we need to alter this bottom one as well now. So let's do it. Must be that one. Yeah. And we'll do the same here. So what I need to do is I need to delete that and that, I think. Same here. That should allow that to drop. And I'll do the same as I did before. So I can get rid of that one. I'll put a dimension on that there to fix that. And then we can sort of leave that one. So these are going to disappear. Okay. And these ones. And that's going to allow me to put that one. That can bring that down to there. And just make sure that is tangent. Yeah, it's done it. Right, so why is this? Stuck in, nothing stuck in that. Right. Oh, that one's going to need moving up. Is that attached to it? It is. What have I got it attached to? That, I think. Yeah, go back up there. Right, where's the other one? Just go wireframe again. And just zoom out a touch. Where's the other one? Actually, is it going to be above that? I don't know. We'll find out. Put some rounded cars in there. Straighten those up. Centralize those. And we'll centralize. And this one is going to be same as this one. So is that one. Yeah, so I made it same width. Actually, what was that? 54. And after that, the right height. 55. Okay. Have I got something here? Must have. Must have. Let's right, yeah, so there. So it's just this way. Why is this not moving? Oh, it is. There we go. So we join that up. And then we must make that tangent. Oh, like something, get rid of it. We got here. Oh, that one. Same as that. There we go. So, right, I've moved my batteries now. Let's just make sure that looks fine. And we'll go at this. Light bug. So, no, not that one. Light bug. Go back wireframe. Go back as is. There we go. Right. Oh, right. It does clash with that. So, where's my motor driver go to? Oh, my motor driver right goes to there. Oh, look, and I've made that too long as well. Oh, I reckon that needs to be a bit back longer there. So this will want shortening. In fact, actually, I need that one for the Arduino. The Arduino screws there, so that goes. But there's nothing on this, so we'll have to get that all the way back. And now I can either shorten that. I've got too much edge. What I'll do is I'll just make that longer there on both of them. So let's just do the top one. Yeah, yeah, I reckon I need to move it up there. So that means I need to just get rid of that. Free that up. That move now. Yeah, that move us back together again. Okay, and then that one there. We will just put a. Do I need to put construction? Right. Oh, I know. Let's see what it's at. Yeah, I need to. I'll just disintegrate. All right, these here. Yeah, so I'll get rid of them. So what I need to do is back up and get the others back together again. There we go. That can go up there. So what we'll do, construction line in, keep that in line with that, like that. Now then, oh, I've moved the wrong frigging thing, didn't I? Like that. That one wants to stay. That one, which is the other one. That's that. Line must be that one. No, that's the one. Yeah, there you go. Right. Get them together. Yeah, that's more like it. Yeah, that should have stood down there, and that should go on end of there like that. Yeah, I like it. And then I can bring that up to there. No, I've done right at the other end. No, I haven't. Right, so that's fine. That one's there. So let's just set that 40 foot. Right. All right, yeah, I know what. Right, so that there, I need to set this length. Yeah, that's looking better. Right, so this side's fine. So what do I need to do on here? All right, I think I need to set this. There we go. Yep. Right, that's done that. Let's put the batteries in the right place. Let's move this back to here. Oh yes, and this was too far forward, this one. So what we're gonna do? Let's just reduce that by that. Can we? No. Hang on. Right, let's just go. Oh, what's that hole there for? Oh, hang on. Which one am I doing? I'm doing the Arduino one. Yeah, that one has to steal it. So, right, I need to do something similar at the bottom. It's just like I like symmetry. And plus, I need this. Make it too weak if I didn't. So let's do this one now. And this one needs that one bringing back. So that's this one. Yeah, so that one should go back. Oh, let's do the others first. Right, so one is, oh, right, yeah, I know. Right, I just need to pick the right center point here. This one up. Which one is it? Oh, right, that's that one. So it's got to be this one. So what I can do is I can put them three together. And that one's free now. Can't move it because I've got this one fixed here. Now let's find out which one that one is. Oh, it's the one at the end of there. So, yep, let's put that together. And let's just do the same again here. So that should be, yeah, that one, hopefully. Oh yeah, that moves that one up. Right, so I need that one to go to about there. So we can set that in stone. Let's just get a dimension across from there to there. Let's make 44, won't it? Yeah, let's set that, and then we can make that vertical. Let's set them. In fact, well, hasn't it actually? It's never set out at all. So it's not changing. Oh, it's this here. Yeah, I haven't got that length. Right, I've got that length there. Ah, right, yeah. That's why that didn't move. There. this wants to be. Yeah, it wants to be whatever it is. What is it? 28? Yeah, so yeah, that wants a vertical adding. So line it up. We stick that in there. Vertical and bingo. Right, and what we need to do is we need to move this one down as we can. So let's just bring that down to about there. Yeah, it's cleared them now. Can make it a bit higher actually. Yeah, about there. So what dimension is that? 0.9, 0.8. Let's make it 50. Yeah, that sounds good. That's actually what I could do. I could make that a bit wider. That make that 60. Yeah, that looks better around this piece. Yeah. So I'm going to go wider. 70. Yeah, yeah, we're going past this piece here now. We'll make that. Oh, 80. Yeah, 80. Yeah, right. Right, let's see what that looks like. Yeah, that's this bottom one there. Look, so we missed the wheel and we missed them now, and we've got plenty of room for our thing. Yeah, and of course this one has the underside down there, so I needed it past both them. I can make this top one wider, but nah, not gonna. Nah, it fits. Where's me? Arduino. Yeah, there's Arduino. I'm gonna fit there. Look, I might make that a bit wider just so it's a bit. Look at straight on top. Yeah, so that it would pass on this side, but we do it on there. Let's make it a bit wider. Use this one in. Yeah. Why have I got 58 now? Oh, because I'm on another one. I was measuring doing the other one. Yeah, right. See, there's 70. Yeah, I'll make it the same as the other one. Maybe 80. Yeah. Or did I make it 90? Oh, I didn't. Must be measure. Oh, I'm measuring from I'm measuring from here before. Right, hang on. Let's do it the same way. Measure from there. We'll put in 80. There we go. Yeah, it's fine to me. Does that? You never know. I might want to mount some stuff on there. Maybe I put a hole in there. Anyways, that's holding them two boards. So now what I need to do is that we need to move this back. Now we're getting onto this timing belt. So let's have a look at our timing belt. Let's get this closed up a bit so we can see what we're doing. Timing tripod. Hang on, let's just click on it and find out where it is. Oh, timing belt. There we go. Can't see the look. So yeah, so if we look at this sketch here, I think it's this one. Yeah, that one there. Oh no, it's not that one I want. Well, which one is it? Oh, time. I'll try this one. Try that sketch. There we go. We can see the sketch there. Now, as before, I mentioned that in some of the other videos, it's good to use a spreadsheet. On the spreadsheet. So yeah, and put the spreadsheet in a separate file because sometimes it's better that way. If I'm going to start splitting up the model into separate components and use it more of an assembly. So I've actually put in a separate file. What's that? Yeah, I don't know what's wrong with my bloody PC. Anyway, there's our spreadsheet. I've put in here some thickness of my tabs so that I can change the thickness of the material. I've got some new board actually, and it's more accurately 3 mil, so I'm going to have to put curve in as well. Deduct the curve from my laser later, and then we'll check that it all fits. But anyway, what I've done is I've also added a variable for gear number of teeth. That's our small timing gear and our large timing gear. So these are variables I can change here. So these are variables I'm going to actually use. So if we look at now that I've increased this wheel, what I want, because I've got a direct drive on this motor here. I have quite a few, quite a lot of ticks on the wheel, so I was hoping it would be okay. But if I can increase this, the better. So what we can do is I can increase the amount of teeth on my timing wheel. So if we got our spreadsheet. Oh, well, actually, yeah, yeah. If we go to, right, yeah, I've never got lost there. Right, so if we look at our timing, my wheel here, and we look at the sketch for it, is that the right one? No, is it? There we Right, it's this one I want. And it's here, right, so which should have been the sketch there. Oh, it is, yeah, there we go, right. So you can see that I'm actually using some variable here because we've got an orange thing. The red is a fixed dimension. Blue is just an information. It's a constraint. So if we look at this, you can see it's just a reference. So it doesn't actually set a dimension. And whereas the red, we don't have the reference ticked. It actually sets it at this. And then if we have an orange one for one where we're using actually this bit here. So we can see in here that I am using my spreadsheet. So you can see spreadsheet there. Right, that first one there with the 2 arrows and the hash afterwards means it's a file. So that's referring to a file. And then I'm actually referring to the spreadsheet, which is this actual is the actual spreadsheet itself in that file. And then we're going to the name of the variable, which is the number of teeth. So to get all the correct teeth to match up, so because we know that a timing belt T2 is 2 millimeters per pitch. So you've got like a 1 millimeter gap and then a 1 millimeter, not gap, tooth, shall I say, a 1 millimeter tooth, and then there's a 1 millimeter gap. So the pitch is basically 2 mils. So we've got a T2, so it's 2 millimeters. So we can only go we need to make this circumference here so that it fits exactly a certain amount of teeth in in 2 millimeter steps, if you get my meaning. It has to be 2 millimeters apart. So to do that, we just divide our number of teeth by 2, divide by pi, and divide by 2 again. And that is, it will give us a radius based on the number of teeth we want, because that's the number of teeth I've set in my spreadsheet. So we can see that, we'll go okay there. So we can see that that is quite it's not like I say, a whole number. We've got a fraction of a number there to get all the teeth fit. So what happens is we close that. Just remember that's about 15.9. So if we close that and I go to my wheel here. So our wheel here, I want to make it bigger. So at the moment in my spreadsheet, I've got 50 teeth. Well, let's give it 60. So we give it 60 teeth here on our large wheel, and let's have a look at it. What I need to do is just go up here. So just go fairly high in the tree. I'll probably go about here somewhere. As you can see, it's highlighting all that lot. And what I'll do is I'll just recompute. And it's got me a solid layer. Let's just go back to this sketch. That is 15.6. Right, so now we're at 19. It should have recomputed when I asked it to recompute. But anyways, okay, so you can see that it's increased, and I've obviously done something wrong with my maths. We'll correct my maths. I think actually it's because it's jumped too far, and I think what happened is that line there should have been over here. Let's just undo that, shall we? Right, so what I'll do is I'll just increase it a little bit. Let's go with a 55 teeth. Okay, save that. Go back. Let's just draw the whole friggin' assembly and recompute that. There we go. Right, yeah. Like I say, something went amiss on one of my corrections. So anyway, I can go a lot bigger than this. And can you see that the belt is also increasing? This is because I'm using variables everywhere. So what I can also do is I can set this distance. If we go to belt again, that one I think it was, right, that one. You see this 30 mil here. I want to move this further out. But can you see that I've actually given it a variable name? And this is timing drive centers. If I use this in my calculations for all the teeth and everything, then this is going to put everything in the right place. So at the moment, let's just turn that on. Let's turn, what else has it turned off? Oh, up here somewhere. There, it's turned off my motor. But can you see where my motor is here? That's I've used this variable that's inside the here, timing drive centers. Use that variable to position this motor. So I want to move this out about another 10 millimeters. So let's make that 40. Okay, that's going to go way out here. Actually, it's not that far. I reckon 35. 35 should do it. So you can see here that I really want this here, and because I've used this variable, If I go to motor again, there's that motor. Now if I go recompute, it's recomputed its position and it's put it in the right place. Also, the timing belt, we can see that timing belt isn't quite right yet. So what we need to do is go down timing belt, one that we're on here, and go all the way up. Let's go to there. Now you can see the timing belt. I haven't actually drawn the ones around the small gear. Yes. The important ones is the one on the top and the one below. So now if I just go and recompute again, hopefully our timing belt now back up, there. You can see that our timing belt has gone to the right place. Let's go down to turn them on. Has that got it? Tick bollocks. Got task and close. There, now it's got it. Now you can see, because I've used them variables, I just need to check this notch here because this didn't work out. Something has slipped. The thing is, when you change size, something can dramatically alter and not correctly make it right. Actually, yeah. I want to put some more teeth in, don't I? Let's try putting 16 there. And we'll recompute the whole bloody thing. Oh, there we are, recomputed. You can see that the motor has actually moved up as well. I don't know if I've actually what holds the motor. I can't remember if I've actually used them dimensions as well. Oh, it looks like it. Yeah, I've even used. Oh no, I haven't. Look, I haven't used them dimensions. I used the variable to set them. What I have to do is go back to the manually. I was only concentrating on the thing. But, yeah, so I reckon I can go a bit bigger than that. Let's try. The bigger the better, because the bigger these teeth are, the more geared down this drive is. So let's just try. Well, let's just try 70, shall we? And just do a recompute. Oh yeah, that looks all right. Is that? I reckon. Yeah. But I've obviously, you can see that I've obviously done something amiss here. I think this here has flipped over. It should be going on the outside. So let's have a look at that, shall we? So we're at this. That's our polar pattern. So that must be our cut. Yeah, yeah. Uh, this has flipped. This one here. This R17. Oh no, I haven't put. Oh, that's why. Right, can you see I've actually put values for these here? And what I should have done is I should have done that and put a value, one of these in here. Although this is a line, is that a line? No, it's a radius. That, I'm sure it is. Right, so what we can do is we can take one of these, like that one, and what I'll do is I'll change it so it adds See this one here, it'll probably do oh, well, if I take this one here, take this one, you can see that I've used the formula here, which I'm using my sketch constraints, and I've gone a -1. So what I'll do here is I'll copy that, and this one, what I'll do is I'll put that in there, but this time I'll make this one a +1. And that puts it on the other side of this mean line there, really. Okay, so that is now going to be like that. And now, because I've made this a variable, that should actually move properly now when I scale up. So yeah, so what I can do is I can just show you that that now works, because what I can do is, let's just change that back to 50. Okay, go back there, and we will do a recompute. Yep. Do a recompute of stuff, and what it'll do is it'll make this timing wheel down again. It'll move all that down. There, you can see it's all moved just by altering that variable. So let's just put it back to 70. I had it, didn't I? And now it should work when I do this recompute. So there we go. I'll put that. Let's put that open like this. Yes. There we go. It's done it right now, you see. So yeah. So we can see that our on it there, we can see that our timing belt lines up with that mark there. What we need to do is check that it lines up with this one here. Now, can you see here where it comes off? This is where we've got to actually watch where it's the position of this. Although I've increased it by 35, what I need to do is so timing belt, that one there. That's that one. What I need to do. Oh yeah, that one will do. Right. So we can see that. See this node point here? It's dead center of that notch there. That's good. Well, it's going to happen anyway, because it's going to come off. And we can see that the top notch here is dead center. If I turn back on the, oops, keep turning it off. Turn on my motor. Go back. You can see that the notch comes exactly in center again. So we know our timing belt is okay at 35 millimeters. I would have thought that would have to be like 2 times. So yeah, so 1, 2, 4, 6, 8. Just 2. Oh, maybe it has to be the odd one to come back here. Yeah, I don't know. Anyway, that's what we're checking for, is that our tooth on our timing belt is going to, in fact, actually, let's just check that. I might have it wrong. Oh, I want that open. Yeah, I need that turned on. Right, so go back here, turn that on, and I also want the timing belt on. The timing belt, we need that back on again. And I need that. Is it that one? Yeah, that one there. Right. This is where I was on about. I also need that one. That on and that one. Right, turns them off. Right. So now we can actually see our timing belts are not lining up. See, so that one there, although I said 35 was okay, It isn't. It needs to be a division of 2. So 2 has to be able to divide into that distance to get these the timer bit to line up. So let's go 36. And add to that, and we will there. So now you can see our timing belt is now in its correct place. So we've gone from this point here, where it sits in there, and then it comes out, and when it comes to this drive wheel, it's now actually in a socket. The thing is, although we went to, if I've gone 35, we could have just turned this round a little bit so that this was in the middle and the thing was inside. But I find it better just to get it somewhere close where we want it. Because can you see that this one here isn't actually lining up? And this is the reason why we need this on a skid, so we can adjust it to its natural position, because this at this height, this is not going to tighten up correctly, because when it tightens up for this one here, it's not going to tighten up right for this one. And we can't turn this to its natural position because this one here is not quite lining up. So we have to see where this node is starting, which is basically at the end of a notch. So if that's starting at the end of a notch, we want this one starting at the end of a notch. So we want this to actually be starting about here somewhere. Yeah. So what I could do is we could actually alter the size of these teeth to maybe just get that to fit a little bit better. So if I was to go with on the small one, the 21 teeth, let's just have, if I can reduce that, large timing belts. Oh no, it's this thing here. What we want is that. Let's just try refreshing that a bit quicker. Recompute. There. So you can see it brought it down. What the hell? Oh, it's because I didn't recompute the whole friggin' lot. Right. There. You can see that this is now ending just on the end of a notch. But we've actually moved in a bit here. There's the end of the notch. We're now about 1/3 in. So let's try get that a bit further in. Let's go with 22. And we'll recompute the whole lot. Right, we're now at sort of like the start of a notch. And we're nearly just gone past start of a notch. So I reckon we're close there. We could keep this up all day until we get it perfectly right. But what in fact we'll do, well, shall we leave it at that? Yes, we can leave it at that, because I reckon what will happen is because we've got this on a skid and we can actually move this back and forth, we can now adjust this bit of offset that we've got with our sliding thing. I mean, it'd be better if it was perfect, but then we need to work out our ratios as well. Like so, we've now got like what is it, a 70-22 ratio? It's not an issue. It's just maths is that when we come to actually compute how far it moves per tick. But I'll just try 23. Let's just try 23 and see if that makes it any better. If it goes the other way now, then we know that we need to go back. No, let's yeah, and recompute the whole lot. Right, so where are we now? We've got our notch. So we're sort of like at the start of a notch there. And where are we now? See, we're at the end of a notch. So I'm going to go back the other way, which was a bit closer. So let's go back to 22. Right, yeah, so now we're sort of like just gone back. So there's our notch, start of a notch. We're about, I don't know, what would you say? One third of the way, or just over one third. And we're sort of like, oh, this is about maybe a quarter, just under a quarter. But anyway, it's close enough. So I'm going to leave it at that. But yeah, I thought I'd do this video about using, drawing it in with timing belts. You need to be able to see what's happening. But to save you sort of every time you do one thing, alter one thing, and then you have to go and alter another thing. Like say, let's just close this. Right, so I've done that, and then we've got this mount that we're going to mount it on. So this mount here, you see, I need to manually mount that to change that. So if we go to this one here, you can see where we've moved this, but I never used any of the dimensions to actually position this shape. What I have to do is I have to manually do this. I have to just go like this, manually put that there. That'll be 24.5, I reckon. That looks good, and the same goes for this. Now then, oh, that's my central there. Oh yeah, there we go, there's that one, isn't it? All right, that was on the center. Right, let me just think about this. What's this going to look like? Oh yeah, I need to leave them where they are, so I don't have to alter this. Right, yeah. Yeah, so we'll just leave that. What I'll do is I'll just take this off this point now, and I'll just move this if I can. Why can't I do that? All right, I see. Yeah, yeah. Yep, that one. Right now then, yeah. I'll just move that like that. But if I'd have used the actual um, variables instead of using these fixed dimensions, what I could do is I could actually, instead of put that on there, what I'll do is I'll put it from there, because that's never going to change. That can be a fixed dimension. 18.5 to the moles. But for this dimension, what I could actually do is I could actually relate that to one of the parameters on the position of this motor that I'm using. So, right, so at the moment I've got on 6. Let's just give that a radius as well. Let's give that 3. No, 4. I just want it to sit in there. Close that. So this one here would really want to be the same as the position of this motor. So if we go and look at our motor assembly, that one there, and we look at its position, it's not that one, this one. At its position, we can see that in the X direction, well actually it's the Y. Now then, this is because it's been, what's the word? It's gone at me. It's been turned 90 degrees inside another object. So the X and Y, the X and Y is flipped to the Y and Z plane. So I think it's the Y one I want. So if I go Y, let's have a look at that. That's 36. And if we go to this one, I set that. Right, so yeah, 30 mil. So is it going 6 mil there? Yeah, it is. Yeah, so this would be what we can do is I know that I've set the actual object by oh, is this making it complicated? Right, okay, so we've got this one here. And it's actually -6, -30. No, it isn't. No. Right, okay, my brain's not working now, but what I could do, I'm leaving it a manual. I can't give a shit. What I could do is where we've gone into here, where is it? This one here. You see, we've moved this position 30 mil, so it would be plus the 6. Well, actually, it wouldn't. It would be the 30 mil. Anyways, forget it. I've got to knock one off the other, and that's why I think I didn't do it before. I do it manually. Manual works. Right, so that'll do. It'll be fine. So what I'm going to do is I'm going to have a go. Oh, actually, no, these holes here. Right, so before I couldn't put big holes in there, but now what we can do is I can actually let's close all this up so I can see what we're looking at. This one, right, that one there. Color pattern, so I'm guessing it's this one. Yeah, that will. So now we can maybe 15, 12, that 4, 14, 5. Yeah, that looks good. Let's see what that looks like. Yeah, that doesn't look too bad, does it? Oh yeah, it looks shit. Actually, what I want to do is I want to reduce the number. Let's go to our polar pattern, and I've got 8. Let's go 7, 6. 6 will do. And so I want to do that for the same for the inner one. So that'll be, yeah, around the right one. So that'll be 6, not 10, 6. And this one. Oh, that one. Solar pan, solar pan. Oh, it's that one there. What did I say this was? 14? Yeah, it looks right. And I made this 5, didn't I? Yeah. There we go. Right, so we've got some nice wheels there. And we've got our, why isn't that? Why isn't that drawing all the way around? Oh, I did understand that drawing. I just didn't draw it, did I? Okay, then. Right. Yeah, well, I hope somebody was able to pluck some useful tips out of there. But I think I've done that. What I'm going to do now is I'm just going to add a few more holes in here, and I'll cut all the bits out. I'll measure and set. Yeah. Next thing is to set the curve for cutting these slots in here. So the thickness is going to change. I find it easy to just change the thickness, and things work out all right. Basically, I could alter the curve when I actually export it to DXF. But well, I'm in two minds. What it is, I want these to be a perfect fit. I don't want them to be a slack fit inside there. I want that to be a really good snug fit. So basically, you push them together and they'll hold together with no glue. But the way I take 3mm, normally it's the tolerance is good enough for my cut, but that's been with the other. I found that with the other material, and this material I've got it smooth on both sides. That means I need to do it a bit more accurate. I think the curve on my cutter is not, yeah, 0.32. So I need to knock off 0.32 number 6. What I can do that is here. So 3 minus 0.32. Oh, all right, maybe I need to write that down. Where's my calculator? Three minus 0.32. 2.68. 2.68. I think I might do a test with that. Anyway, that should have altered my thickness. I shall compensate for the. Oh, yeah. Go on then. It's just. Let's do a recompute, shall we, just to make sure. No, but it used to do this automatically when you do this, but things are changing. Oh, there we go. I noticed things change. Yeah, as you can see here, it's changed there. So what I might do, might actually, because of the timing belt, yeah, I think I might leave it at 3 mil and then alter the curve in the actual cutting pieces. Yeah, I'm going to do that. I'm going to change that back to 3 mil. Yeah, just swings and roundabouts. Swings and roundabouts. So, yeah, if you look at this wheel here, they see it pop out. Look. That's because I made it thicker. And so things are lining up right here now. And I'm going to sort my curve out actually once I've created the DXF files. What I found is creating a DXF file, let's just create one. We can turn our floor off now because, well, if we look at our floor, we're sitting nicely. I could have made this a bit longer actually, but I think I'll leave that more to overlap like that. It doesn't look too bad. Yeah, it's got a style to it. Right, yeah. So, yeah. So let's get rid of the floor. Uh, like I say, the mirror image. See these two here. These two are mirror imaged, and then when I mirror image a mirror image, it doesn't quite work out. It ends up missing one. It only mirrors one of them for some reason. If anybody, any KiCad devs are on watching, ever see this? It's an issue. Anyways, so the way I create a DXF file is we'll start with the floor. Now they've done a new DXF, right? So let's just have a look at the options. Preferences, and we'll look at the export, import, export, and we'll go to DXF. So we've got our settings here, and we could use a legacy Python exporter or not, or the one built in. Now I'm using the one built in because the legacy exporter does not do things like this. See these holes here? I did a one of these hole pattern and exporting a DXF in the old legacy. It doesn't do polar patterns. It misses them polar patterns out because there is an issue. At one time, we could choose this and export this as a DXF. Can't do that in the legacy one. What you have to do is you have to actually pick sketches. So you have to actually select the sketch. So when you actually select it, oh, let's go to this wheel here. So when you're actually selecting the sketch, you can see we're missing off the polar pattern, and so it won't do the polar pattern. You used to be able to just select this and it would do everything in here and lay it as a one flat plane. But it doesn't do that now. It comes up with an error because it tries to do like a 3D thing. So I'm not using the legacy. And now with the non-legacy, we can click this and we can do a DXF file. Right, so let's just do that basically. So let's do that wheel, timing wheel. Go export. We're in the DC. Let's create a new folder. DXF. And so what we'll do is we'll export that here, large timing gear, and we'll have a look at it, shall we? Uh, bring that. Let's have a look at DXF and we'll have a look at this. Right. Oh, no, no, it doesn't call me right. Right. So that has done the rotation, the polar rotation. But the thing is, right, so if I select it, can you see there's actually two? There's the top one for the top layer and there's the bottom one for the bottom layer. I just want one layer. I just want a 2D DXF. So if you notice when we went to export this, when I went to export this, right, down here, uh, we've got the choices of what we want to do, and it says Autodesk DXF 2D. It says 2D, and that's what it should be, 2D, but it isn't. If we this app I use, LibraCAD, it only does 2D, but you can see that there is actually another layer underneath. This is the body. It's done the body and it's done two layers. So if I select, just escape on that. If I select one, I can delete that and it still leaves another one. Same goes for this. Can you see? There's another one underneath. We've got two layers. There's two layers. And I have trouble separating them. So what I do is when I actually come to do something like the wheel here, this one, I'll leave it in the normal. I actually don't know what. Right, if it's got a polar in there, I will do it the way I've just done it. But if there's no polar in there, what I would do is I would then do I would just select the sketches, right? And so, but the thing is, it's going to miss these two polars out. So if we sort of export it again, and we have another look at it, bring it in, you can see that it's missed out the polar, and it's actually drawn the sketch itself. So what I would have to do is I would have to select this and do my own polar. So then I would just copy that, go back in the same place, and we do multiple. We'll do what they say 70. Well, actually, with this, yeah, it's 69, a total of 70. We've already got one. We want to do another 69. And it's 360 divided by 70. Okay. And that's what I'd have to do. And then I'd have to edit and cut all them. But there's a trick actually here. So instead of editing all of them, what I would do is I would edit one. So this line, I just want this bit. And what I would do is I would cut that, cut it there, delete that. This line here. Oh, actually, undo that. Before I delete it, what I would do is, let's do it the same on both sides. Doesn't matter. So now I'll cut this line here as well, and I'll cut this line here. And yeah, that's it really. And then what I would do is I would delete that line, delete that, delete that, and delete that. And what I've got is that bit there. So all these, let's get rid of them. Well, I wouldn't do them in the first place, right? So what we'd do is, instead of what I did before, I would select them, and then I would do the rotate center. I've deleted the middle bits. And do okay. And then, oh, what the fuck? I've done something wrong there, didn't I? All right. Anyway, what did I do? I wasn't paying attention, was I? Right. So I got them. Have I moved that? Right. So rotate center, center, 69. Hang on. What have I done here? Let me just back up a touch. Oh, that's the frigging hole there. There's the center. Oh, God damn. Oh, dear. Right, pick this center this time. Right, so yeah, so there's my center. I'd do it again. So that now I've ended up with them, and all I have to do is just select them all. Oh, might as well. And then just make them into a polyline. So now that's a polyline. Yeah, so that's what I do, and then I'd just do the same with this basically. What did I do? 6 of them, didn't I? So it's just that, and then we'll just do 5 more to make 6, and 360. Oops, 3, what am I doing here? 360 divided by 6. Yeah, there we go. And that's it, really. That's what I'll have to do. In fact, yeah, we'll stick with that. Right, that's the preferred method, actually. Because the other way, I'm trying to find out which ones we've done and which ones we have. Yeah, there's lines underneath the other one, and it's just a pain in the ass. So it's not hard to draw all that in there. So yeah, that's what I'm going to do. I'm going to just add a few extra holes in this plane, and then I will create my DXF files, and I will cut them out. So yeah, like I say, I hope someone's maybe picked some bones out of what I've just done there, and something made sense about this timing belt. A timing belt has teeth in it, and they're 2 mil apart. So basically, the teeth have to line up on both wheels to make a neat match. Otherwise, you're going to have one of the belts. It's going to be slack on one side. You're not going to be able to tighten it up. Well, you can get away with it on a skid here. What I've done is I've put a clamp there, and what I can do is I can move it back and forth, tighten it up, and it'll find its own centre. But you need to get it somewhere close to start with, otherwise you're going to be a mile out. It can be at least 2 millimeters out of where you need to be. Anyway, I'm waffling again, aren't I, guys? I just you found something interesting. Right, I'm going to leave it at that.